Assalamu alaikum, doctor. In our operating system project presentation, we are from section 3, UNIX Hunt. Our project topics are process scheduling, round robin, and multi-level queue. Basically, our group UNIX Hunt consists of 5 dedicated members who are doing very great jobs to complete this project. Without their proper collaboration during this pandemic situation, it was very tough to complete this project. So, they are Ridwan, Arnav, Akib, Tanvir, and myself, Bayas Ahmed Shuhartu. Now, what is actually process scheduling in the operating system? The process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basics of particular strategy. Process scheduling is an essential part of multi-programming operating system. Such operating system allow more than one process to be loaded into the executable memory at a time, and the loaded process share the CPU using the time multiplexing. So, our group member will discuss more about process scheduling, basically round robin and multi-level queue. Thank you.
Assalamu alaikum. I am Golamosi Arnav from group UNIX Hunter. So in this video I will describe about the round robin algorithm. So what is round robin algorithm? So in round robin algorithm, each process gets a small percentage of CPU time in turns. After each turn is finished, one process is removed from the queue and another process is added. This continues until all processes have completed their job. So let's explain that through an example. 4 processes A, B, C, D each come to CPU 1 second after. So the CPU time slice is 4 milliseconds each. The processes need 8 milliseconds, 4 milliseconds, 9 milliseconds, 5 milliseconds respectively. So what it will do is, in the first round, each process gets maximum 4 seconds in turns, or else they get the minimum time they will need to finish their task. This repeats until they finish the task. So in the next slide I will describe how it works. So here we can see that there are 4 processes: job A, job B, job C, job D, and the burst times are 8, 4, 9 and 5. So from this Gantt chart we can see that job A will continue his process until 4 milliseconds because the CPU time slice is 4 milliseconds each. So after 4 milliseconds, as the job A burst time is 8, so 8 minus 4, another 4 milliseconds is remaining for job A. Now job B will start. We can see that the burst time of job B is 4 milliseconds. So from 4 to 8, job B will execute. After that, job C will come, and job C will continue until 8 to 12. So after 8 to 12, we can see that the burst time of job C is 9. That means 9 minus 4 is equals to 5. So another 5 milliseconds is remaining for job C. After that, job D will come. It will be there until 12 to 16. So 5 minus 4 is equals to 1. So another 1 millisecond is remaining. After that, this will come back to job A again, because job A is not finished yet. So as we already said that for job A there is 4 milliseconds remaining. So from 16 to 20, job A will be processed again and it will finish executing. And job B is already executed successfully, so it will not come to job B. Then it will come to job C. So 20 to 24, it will continue to job C. So before it was 9 minus 4 is equals to 5, and now 5 minus 4 is equals to 1. So another 1 millisecond is remaining for job C. After that, job D will come. For job D, only 1 millisecond is remaining. So from 24 to 25, job D will execute. After that, as job A, job B is finished executing, so job C will now execute, because 5 minus 4 is equals to 1. So another 1 second, here we can see that 25 to 26, and it will finish executing job C. That's how round robin algorithm works. Thank you very much.
Assalamu alaikum, I'm Ridwan bin Munjur and I will be explaining multi-level queue algorithm for my team UNIX Hunt. In a multi-level queue scheduler algorithm, there are two important things to remember. Firstly, all processes are permanently assigned to a queue based on some property, and the queue will have priority, meaning that it will get executed before a queue with lower priority and after a queue with higher priority. Secondly, the queue will have its own scheduling algorithm, which means all processes inside that queue will be executed by only that previously stated algorithm. So let's explore that more through a problem. In this example, there are 4 processes: process A, process B, process C, process D, which come to the CPU in 2 queues. The first queue has more priority than the next queue, and each queue has its own CPU algorithm, CPU scheduling algorithm. So the first queue with more priority will get executed before, and it consists of process A and B, and the second process consists of process C and D. The first processes will get executed by round robin algorithm and the second by first come first serve algorithm. So this shows the arrival time and the burst time. The arrival time for all processes are 0 seconds except for job D, which is 10 seconds, and the burst time is 10 milliseconds, and the burst times are also stated, and queue number the queue numbers are also stated, which actually corresponds to the priority of the queue. And as you can see, the first 2 processes are executed by round robin algorithm and the next 2 processes are executed by first come first serve. So the Gantt chart shows the solution of how these processes will get CPU time. So process 1 and process 2, process A and process B belonging to the first queue will get executed at first. After they completed, the next queue will be completed. The next queue will get CPU time. So as you can see, because this is a round robin algorithm, it finishes in round robin fashion, with each process getting a time slice of 2 milliseconds. After that, job C and job D start getting executed, and they're executed in first come first serve. Since job C is executed, since job C has arrival time before job D, job C will get executed first and job C will complete. After that, job D will complete, and with that, all these 4 processes belonging to 2 different queues get executed. So basically, this is the example of the round robin. This is the example of a multi-level queue algorithm. Different processes belonging to the same category of processes will belong to a queue. For example, all processes related to input might belong to a round robin algorithm queue, and then you have processes that require immediate attention, they will belong to another queue. And for example, you have batch processing, you have batch processes, so they will belong to a different queue and they will have their own appropriate algorithms. And that was the basic idea behind a multi-level queue algorithm. I'm Ridwan bin Munjur, and thanks for giving me an opportunity to explain this.
Hello everyone. For the conclusion part, I am going to tell about our task allocations. So we contributed 5 people to this project for operating systems. So my first groupmate was Baez Ahmed Shorto, who did the web design, animation, and introduction part. My second groupmate was Ghulam Wasi Arnab, who did the web designing, thinking, and round robin part. My third groupmate was Akibul Hassan, who did the video compilation, CSS, and JS effects. My fourth groupmate was Ridwan bin Manjur, who did the animation multi-level QE part, and the fifth one was me, which is Tanvir Sakline, who did the carousel, JS, and conclusion part. So once again, I would like to thank Dr. Zurihati Yunus. Thanks, Doctor, for teaching us through the whole semester, and best wishes for you for the next semester, Doctor. That's all from me. Thank you, guys.